So some serious topic now, that is called free body diagram, and your Newton's law of motion, I can tell, starts from here. That is you can expect one or two numerical from this FBD. I will be telling it as FBD, that is free body diagram, remember. And in your school exam, your final exam or all India exam, definitely that will be coming. What is free body diagram? Remember, these are called force distribution diagram. Means these will be doing the introductory part now in class 11, and this is the chapter from civil engineering or mechanical engineering semester 2. There will be learning this load distribution formula, those things. So free body diagram means will be just marking the force acting on that body, and remember, the tension acting on the string. We will be assuming that the bodies are joined together with the help of a string, and remember, those will be massless and frictionless. All of throughout class 11, 12 we will be learning about the ideal case massless spring like this. So in case of free body diagram, remember a few things. All the masses should be denoted by a point mass. That should be easier for you, but in time of doing the problem, I'll mark those masses as mass, not point mass. So remember, the first point you have to know, that is, you have to consider the force acting on the body, which is, remember this word, acting on the body, not the force which is created by the body. All the forces which is acting on the body. Number two, another thing is very, very important, that is called the frame of observation. That is, I can tell it as frame. So what is frame? Remember, that is observer. Observer means, see, the person who is actually visualizing all those things. That is observer. Remember, now again I'll start Newton's first law of motion, that is called unless a external force is applied, the body at rest will be at rest, the body in motion will be in motion. That is called inertia. So there are two types of frame. One is called inertial frame, another is called non-inertial frame. See here. So frame can be classified basically into two categories. One is called inertial frame, another is called non-inertial frame. Inertial frame. And remember, the simplest thing by which we can assume this. Inertial frame means when the observer is at ground. As simple as that. See here. So we will be taking reference when the observer is at ground. Remember this one. So what is this? See here. A car is moving, a vehicle is moving, and this is ground, and the person is standing here looking to it. This is called the inertial frame, remember. So when the observer is at ground, that is called the inertial frame. Now what will happen? Non-inertial frame means, see here, this is a moving vehicle. I have told you in time of relative velocities, I have told you this body is moving with certain velocity v. Another person is there who is inside that vehicle. So if he is the observer, see here, if he is the observer, then this type of frame is called a non-inertial frame. So in time of free body diagram, consider the force acting on the body. This is important, and we have to take the reference frame. In class 11 and ISC, we will be dealing with inertial frame, and when we go for the joint and all India exams, we will be going into the non-inertial frame. Basically here, And one more thing I'd like to tell you, that is frequently they are asking this question for the last 2-3 years, that is called assumptions made. So in time of free body, I have not started yet. So in time of free body diagram, the assumptions made. So these are the 1 mark question in exam hall. If you find it very difficult to answer this, number 1, say one thing is hanging from a string. This is mass m. So naturally we can tell the weight of the body is acting downward, and the tension force or the tensile force acts on this thread. So remember, this thread is non-stretchable or non-inextensible, we can see. So here we'll learn another chapter, that is called elasticity, where we'll see when we apply force on a thread or a string, that string will elongate. That is called elasticity. But here we will be assuming that the thread or the string or the spring, whatever they will give, will not expand. So it is a non-extensible string. It is a non-extensible string. So the string will not expand. Whatever load you will put, the string will remain same. That is the ideal case. That never happens. And number 2, see here, we will be dealing with few problems related to pulley, many problems related to pulley. See here, this is mass. We have learned it in class 10. This is effort. So here the pulley starts rotating. Remember, here this thread goes on through the pulley, but there will be no friction. It sounds impossible, but it is true. We will be assuming the frictionless. So here we should learn this thing as frictionless. Remember, frictionless. So these are the basic 2 assumptions, that is the string or whatever the mass is attached is inextensible, that is it will not elongate or compress. And number 2, the pulley, the mass, whatever you are assuming is on a frictionless plane. And here one more thing you would like to keep it in mind, that is whether the frame is inertial frame or non-inertial frame.